Hey, Mr. Stride here. Today, 8.3, we are going to cover state on objects, instance fields, behaviors. We're going to talk about how to write methods into them, use them. We're going to use a fraction class. You're going to like it. Stay tuned. Watch it.
Let's create a fraction class. We have, in the past, done work with fractions. We had a fraction calculator. Wouldn't it be nice if we had a fraction class that did all the work for us? We'd have to write it. What would a fraction have? I think a fraction has a numerator and a denominator. I'm going to shorten it like that. These are called, instance fields. So my fraction calculator is going to have a constructor. And in my constructor, I'm going to say, you need to give me the numerator and denominator in order for me to create it. When I create my fraction, I need to set the instance fields that I have. I need to make sure that I use the this operator to set the numerator to the numerator, and I need to use this operator on the denominator, so that way I can differentiate between this num and this num. So this num is this one up here, and this num belongs to the formal argument right here. This creates my fraction calculator. All right, so now I have a class that will actually represent a fraction for me. What would my fraction do? What would the behavior of a fraction be? I know, maybe add. So I'm going to add to my fraction by saying add. And then it'll take a fraction f1 and fraction f2. And what will it return? I have no return type here. It'll return another fraction for me. Up here I have no return type. You know why? Because it's a constructor. And constructors have no return type, none at all. We haven't learned that yet. We'll get to it later, but you have to kind of accept it on faith. So I'm going to take a fraction. I'm going to add these two fractions together. But you know what? I am a fraction. This object is a fraction. So really, instead of adding two fractions that I don't know about together, why don't I add just one fraction to myself? So I'm going to add this fraction with this numerator and denominator to the other fraction that comes in. All right, let me be lame. I'm going to add them together. You want to know how I add them together lamely? Int numerator equals this numerator plus I'm waiting for you to say it. You're not saying it. Other numerator. There you go. This is like Dora the Explorer. You got to say it with me. Int denominator is going to equal this denominator plus other denominator. Okay. This is horrible math. That's not how we do math. That's not how we work with fractions, right? We actually need to get the common denominator and add them together, right? We've done this before. So the common denominator, int common denominator is going to be equal what? How about if I take the other denominator and multiply it by this denominator? That means that my new numerator is going to equal what? It's going to equal this numerator times, come on, say it with me, the other denominator. And then int other numerator is going to equal the other numerator times this denominator, right? So I'm doing cross multiplying of the fractions. I created my common denominator, which is just multiplying those two together. Then I have to cross multiply to get the numerator and denominator. So what is my result? My result is a new fraction, right? My answer is going to equal my numerator plus other numerator. But that's the numerator. How do I make that the numerator? I'm trying to create a fraction with that. Gosh, I need to create a new fraction. Oh, new fraction. And I want this to be the numerator. So let's just add that in to my constructor as the numerator. What's my denominator? It's the common denominator. There I have my new fraction. I can return it like that. This is garbage. Get rid of that. I love deleting code. Gone. I now created a fraction. What did I do? I took myself, this object, this denominator, this numerator on myself, and I added it to the other fraction. I've created an object that represents the abstract concept of a fraction. I have numerator and denominator here. I made them public. Is that good encapsulation? Is that hiding the stuff that I want? As we learned in our previous one, no, we need it to be private. What if I make it private? Will this still work? Who knows? If I make it private, what do I need? I need to have getters. So I'll make my getters public. It'll return an int. I'll get my numerator. Simply return my numerator. And then I'll have my get denominator. And I'll return this denominator. Now I have my getters. Will this work up here? Just going directly into the object? Well, when I make this private, it means the only characters, the only code that can access the internals of a fraction is a fraction class. So some languages don't let you do this, but in Java you can. So I can go into the private parts of another fraction object as long as I am a fraction object. So this is fine. But if I didn't like it, I could just do like this. Get denominator. Okay? Other get denominator. Other get numerator. So now I'm making sure that I'm not breaking any of the encapsulation principles of hiding the internals of a fraction object. Private instance fields with a numerator and denominator, creating a constructor that has a numerator and denominator, and I set my instance fields to those that have the same name. Create a behavior. This is a behavior. I'm going to add myself to another fraction. I do some crazy math. Hopefully it's right. If it's not, you'll forgive me. Then I create a new fraction object, and I return that fraction object because that was the type I wanted to. You know what? Let's shorten up this code. Return new fraction. Boom. Love it. I have my getters and setters so I can keep my internals private if I want to, and I am done. Do I know if it works? I have no idea. Let me save it. Save my file. Do I want to save it? Yes. I told you I wanted to save it. Let's go into here. Do I want this? Nope. Okay. I'm going to create a new fraction. Fraction f1 is going to equal new fraction 1/2. Fraction f2 is going to equal new fraction 1/2. Fraction answer is going to equal f1. Oh wait, how do I add? I want to add f1, f2, but I just took that away, didn't I? I said we're not going to do that. You guys know? You're right, f1 dot. I can use the dot operator on my fraction. I can add them together. This will add f1 to f1. Don't want to do that. Add f1 to f2. Or I could do add f1 to f2. Either way. Then I get my answer. Now I want to print it out, right? Let's print it out. System dot out dot print line. What would be nice? Oh, I'd love to be able to just print my answer like that. What if I compile this? Kind of works. You know what's going to happen? It's going to be weird. You ready? Guess what's going to happen when I hit run on this guy? What the heck is this? You know why I did that? Because A is an object. An object, when I print it, will print out the address of it. If I wanted to print nicely, I need to go in and I need to update my fraction object to have a toString. So public string toString. Now it'll print nicely. I'm just going to return the string. What am I going to return? I'm going to return the numerator added to this little slash guy plus my denominator. I don't have any other arguments with num. I can just use num here. I don't have a num in here. Like I had up here, I have an int num where I had to use this num. I could just use num there. But if I really wanted to be clear, I could say this num, because I'm talking about the num that belongs to this object. This object, no static. If I had static here, I wouldn't have a this, but I have a this, so no static. Let's go back to my other method. Let's run this puppy. Okay, do you think it's going to work? Let's see. Didn't work. Didn't do what I wanted it to do. Fraction, public, toString, string, toString, return this. Return A. Let me run it again. Oh, let me run it over here. I still get the address of it. All right. I need to figure out what the heck. Why isn't it calling toString? String, toString, return this, string. I have no idea. That should totally work. All right. I know what it is. I know what it is. I forgot to put into my project the fraction class. I just need to go up here, grab my fraction object, put it in there. Once I grab that in there and put it in, then when I hit run, the output is 4 over 4. Is that right? 4 over 4 is 1/2 plus 1/2. 4 over 4? In fact, it is. I didn't reduce. So in my print string and my print, I could reduce. But that's an exercise for another day. So what you can see is that we were able to create a fraction class that encapsulates the abstract concept of a fraction. We're able to create an instance method on the class, an instance method add, that took another fraction and added them together. That's pretty cool. Let me show you something else. What if I wanted to add a static method that returned a fraction and added 2 fractions together, f1 to f2? How would I do that? Well, I would simply ask f1 to add f2. That's kind of weird. I could totally do that. I'm going to ask the fraction f1 to add f2. Then when I'm back over here, I can go like this. I can say, hey, fraction class, I want you to add f1 to f2. The add method belongs to the fraction class. When I run that, believe it or not, I just ran it, you didn't see it. I got the same answer. Same answer. Which one do you like better? This one? Or this one? This one may seem a little more familiar to you, but in computer science, this is the style that we prefer. We prefer to ask objects to operate on themselves so that objects have the behavior. What is the behavior? Behavior is what they do, their methods. This is the behavior, add. Also has some accessors, or accessors. You know, we call them accessors because they access the internals of the object. And then we have things here, which are their instance fields. That's what it has. All right, I think I'm done. We've covered everything. Hope you enjoyed it.